Troposphere is the zone of mixing of all gases. Okay. Tropos. The tropos mean mixing. Mixing of all different gases is troposphere. Zone of mixing of all gases is troposphere. Troposphere is the zone of mixing of all different type of gases. Troposphere. Right? In this troposphere, as I have just mentioned, zone of mixing of all gases, troposphere, lowest layer of the atmosphere. This particular region is in fact, truly speaking, this is the zone which is responsible for almost all atmospheric phenomena. Lowest layer in our atmosphere. Its thickness varies from the equator to the poles. Equator to the poles. Its thickness varies from equator to the poles. It is 8 km near poles and 18 km at the equator. At the equator it is 18 km. 18 km at the equator. 8 to 18 km variation is there. Why this variation? Let us see now. Why this variation? We will see now. Remember, this is the troposphere here. This is the troposphere. Here you have the equator. This is the pole, North Pole. Here you have the South Pole. Remember, at the equator, temperature is very high, because of which what happened, this air parcel goes upward. Why? High temperature leads to high convectional instability. At the equatorial region, you have temperature is much more. Temperature is more at the equatorial region. Temperature is very high at the equatorial zone. So, more convectional instability takes place. This leads to the vertical rise in the air parcel. Okay. Up to 18 km disturbances you will have in the upper part. At the equator, 0 degree equator it is, 90 degree it is pole. So, near the equator, the most important thing here happen. What is there? Near the equator, the convectional instability is much high. So, the convectional, this part, you know, it moved upward. Okay. So, here you see here that the equatorial region, at the equatorial region there is vertical rise in the air parcel. Why? High temperature leads to low density of air. Low density of air leads to upward rising of the air parcel. When the air parcel will move upward, it goes upward, because in the upper part of the atmosphere the pressure is bit less, so it got diverged, like ऐसे हो जाएगा. When it goes up, it goes like diverge like this, goes up, diverge like this, right? And this leads to, when it goes up, it diverges, and this particular phenomena leads to more convectional instability. This leads to increase in the height of the zone of mixing of different gases. So here it is up to 18 kilometer height. It goes up to 18 kilometer height. Here also up to 18 kilometer height. Here is nearly 8 kilometer. Here is nearly 8 kilometer. So this particular zone is primarily associated with thermal factor, temperature. You remember, with increasing height there is a decrease in the temperature also in the troposphere. This is known as the lapse rate. आप देखो, आप अगर कोई हिल स्टेशन में जाते हो, हाइट के साथ साथ टेम्परेचर घटता है ना, व्हाई इट इज देयर? Can you see this? And look at it, very, very important it is, in fact. Okay. Okay. Now, you can see this like okay, fine. Look at here. In this case, if this is the earth here, here temperature is more at the equator, because of which high temperature, convectional instability is more, so air will move upward here. It is going upward. It is like convectional instability is there. If you remember, I told you earlier that we have a very, very important one point. I told you earlier that whenever you are boiling the water in a particular regions, whenever you are boiling the water from below goes upward, and it will have like circular movement. Likewise, air will get a convectional instability here, so it move upward. It goes upward. Because it goes upward, here the mixing zone is much higher. But here it is like this polar area you have at the poles. What is here? At the poles you have, at these both north and south pole, high pressure belt. Sinking of the air you have here. Air is sinking, due to which the convectional instability is not there. Sinking of the air leads to lowering of the zone of mixing of gases. So, you have 8 kilometer here, 18 kilometer here. I hope you got it now. Here you have 8 kilometer at the poles. At the equator you have 18 kilometer, and this is here is the zone of mixing of all gases known as troposphere. Okay, clear? Eh? Next point, troposphere is associated with almost all major atmospheric phenomena, like almost all atmospheric phenomena like cloud formation, precipitation, cyclone, anticyclone, cyclone, anticyclone, cloud formation, precipitation, cyclone, anticyclone, etc. जो भी है एटमॉस्फेरिक सर्कुलेशन, एवरीथिंग इज रिलेटेड विद दिस पर्टिकुलर जोन. क्लाउड फॉर्मेशन लेके अभी तक कोई भी है, एवरीवेयर इट इज एसोसिएटेड. ओके. ट्रोपोस्फियर इज एसोसिएटेड विथ ऑलमोस्ट ऑल ए मेजर एटमॉस्फेरिक फेनोमेना लाइक क्लाउड फॉर्मेशन, प्रेसिपिटेशन, साइक्लोन, एंटीसाइक्लोन, एटसेट्रा. व्हाई? Because this zone comprises more than 95% of all atmospheric moisture and more than 95 nahi, more than 99% of all atmospheric moisture and 95% of all atmospheric dust particles. I told you wherever you have dust particle and wherever you have moisture, they will definitely act in a different way and it will have major impact. This will also happen with this particular region. तो क्या होगा? What will happen here? Let us see. I said almost all major atmospheric phenomena is associated with it. Almost all major atmospheric phenomena is associated with it. You remember that this zone has one more very interesting thing. With increasing height, there is a decrease in temperature. In the troposphere, there is a decrease in temperature with increasing height. Called as or known as इसको क्या कहते हैं? lapse rate. Lapse rate is around 6.5 degrees Celsius per kilometer. Okay, you got it? Just look at this. What is lapse rate? I'll ask you. Lapse rate होता क्या है? Can anyone tell me? क्यों होता है ऐसा? Any idea why there is a lapse rate? Why there is a decrease in temperature with increasing height from the surface? Decrease in temperature with increasing height from the surface. Yes, no idea. There is a decrease in temperature with increasing height because let me tell you, our Earth atmosphere get heated up due to terrestrial radiation. आपका हमारा तो अर्थ का जो एटमॉस्फेयर है ना, you remember always, if this is the earth surface here, if this is the earth surface, From the sun you are getting the, as you know, all of us were well aware, you are getting here the short wavelength, and it is radiating at long wavelength. This is incoming solar radiation known as insolation. Outgoing one is known as terrestrial radiation. Incoming solar sunlight, insolation. Short wave insolation. Outgoing long wave terrestrial radiation. Okay? While it is going out. While it is coming, it is known as terrestrial. Here is coming, it is known as the, what is this? Insolation, incoming solar radiation. While it is going back after reflecting, terrestrial radiation. Very good, very good. Thank you very much. Chalo, answer. Just I got the answer. Due to decrease in the density of air with increasing height. Very good. There is a decrease in the density of air with height. Yes. Denser air, less denser air. Lightest air is here. Because of sun heat on the surface you have, here insolation आ गया short wave में, terrestrial radiation से ही atmosphere get heated up. ठीक है वंशिका? Due to less water vapor present at height. Yeah, that is also a cause. Water vapor is less. That is also one triggering factor. Yes. Long wave terrestrial radiation reflect back from the earth surface. Very good. Also heated up due to terrestrial radiation. Yes. Earth atmosphere get heated up by the short wave nahi. It is atmosphere get heated up by the long wave terrestrial radiation. Okay. Which impact will goes on decreasing if it will go up. Very good. Thank you very much. आप लोगों को पता है. I am really very happy. So climatology में थोड़ा पढ़ा है क्या है लग रहा है. Geomorphology में पूरा एकदम वहाँ पे basic things you got it. Thank you very much. You have some idea. Very good. Now what I am saying is, as you know, here it is coming, short wave is coming here, reflected back as a long wave, terrestrial, and earth atmosphere got heated up because this one, terrestrial radiation. Now while it comes down, reflected back from here, density of air is more in this part, so more quickly it can transfer, but here it will go up, density of air is less. These are the major factor, two major factor for which with increasing height there is a decrease in temperature. Okay. Now the terrestrial radiation, here it is different with the different gases. If you have dry air, normal air, then you have wet air. wet or moist air. Wet or moist air. Three types of air you have. If you have a, let us say, you are somewhere with your friend. Let us say here is the place with dry air. Here is a place with normal air. Here is another place with, hello, this is dry air, normal air, moist air. Now you tell me one thing, wet air or moist air. In these three cases, ABC three places, let us say, ABC की जगह मैं नाम लिखता हूँ, ये लगा जैसलमेर. You are at Jaisalmer. Here at, let us say, Bhopal, and here someone at, let us say, Kolkata. Kolkata. Jaisalmer, Bhopal and Kolkata, three places I am saying. At one place you have dry air, we have normal air and wet air. Kolkata you have moist air, let us say. Among these three places, if we will see, ये तीनों जगह में, if we will look at the rate of change of temperature with height, it will differ. जैसे मैंने कहा था ना, normal लाफ रेट कितना है? 6.5 डिग्री सेल्सियस पर 6.5 degree Celsius per kilometer. It will decrease with increasing height. This is called a normal lapse rate. Normally it is this. So at Jaisalmer, but if the dry air is there, it cool down very quickly, heated up very quickly. You know that the air with the moisture अगर है तो वो temperature को retain करेगा long time. You know it. You have the dry air here. Dry air, cooling of the air will be very quick. Also warming up will be very quick. So in the case of dry air, Jaisalmer, it is in fact nearly 9.5 degrees Celsius per kilometer change, and compared to this is Kolkata, if you will go for, it is around 4.5 degrees Celsius per kilometer. So ये on an average जो है ना तीनों जगह पे अलग अलग होंगे. So at the same, let us say if I will go for 10 kilometer height in both all these places, whatever 10 kilometer height, if I will go for 10 kilometer height from the surface, whatever may be, it will turn into a minus 95 degrees Celsius, it is minus 65 degrees Celsius, minus 45 degrees Celsius. So likewise, if it is 0 degree here at the surface at all places, let us assume, then it will be like this. Equal temperature अगर तीनों जगह लेते हैं तो ऊपर जाते जाते टेम्परेचर घट जाएंगे. Okay. So in this case, this type of variation, they are asking question: wet adiabatic lapse rate, dry adiabatic lapse rate, normal lapse rate. This is known as the wet adiabatic lapse rate. ये जो है ना, this is known as the wet adiabatic lapse rate. This one. This is here the dry adiabatic lapse rate. Dry adiabatic lapse rate. Dry adiabatic lapse rate. This is here is normal lapse rate. Normal lapse rate. Normal lapse rate. Three types of lapse rate you have: dry, moist, and this. So in case of dry lapse rate, in fact, sudden change in the temperature will have. In case of moist, it takes time, and that's why you have climatic phenomena also will have differences. You see, in the desert regions, during the night, the temperature goes down even to single digit. In the daytime, it is around 45-50 degrees Celsius. Night time, it goes to 9 to 10 degrees Celsius. So this type of variation is because of dry air there. Okay. So ये जो है, it means moisture plays a very important role. 6.5 degree is the general lapse rate here in this case. So, if I will go for these particular regions, as I was just drawing this diagram showing this area. So, temperature will decrease here with increasing depth, increasing height. You see here is sinking of the air because of cold air is denser, so it is sinking, it is going upward. I have just said this is known as tropopause.